Okay, so welcome everybody. This is session 3.1. We have a couple exciting topics for you today on the subject of energy use within buildings. So each presenter in this stream will have about 20 minutes to present, and like the presentations before, there will be a brief question and answer period. So be sure to type in your questions into that box on your screen. First up, we have James Sharpe, who will be doing a presentation on energy audits. James is an electrical engineer here in our Edmonton office. He has 10 years of experience within the industry, and 5 years of those is specific to the design of electrical building systems. James has received a CEM designation just last year, I believe, which makes him a certified energy manager. And he is also an individual member of the Association of Energy Engineers. I personally had the pleasure of working with James on several projects and can attest that he's a fun guy. He's passionate, and he is great to know when you have those tough energy and electrical related questions. So without any further ado, I would like to welcome James in his presentation on energy audits.
All right, let me just take off the cover there. Hopefully you can see me well. I'll share my screen. Carl, can you let me know if there's any issues with sharing here? You can see it, I assume, Carl?
Yeah, it's looking good, James.
Okay. So as Carl said, my name's James Sharpe, and today I'll be presenting on energy audits, the benefits and the uses. So the outline today will be essentially I'll talk about what an energy audit is, energy audit levels, benefits, disadvantages, and I'm hoping there's time I can briefly talk about an example project as well. So first, what is an energy audit? So an energy audit is an in-depth examination of a building's current energy efficiency levels and usage practices. It focuses on cost-effective solutions for maximizing functionality and efficiency while minimizing a building's energy usage and expenses. A too long didn't read version of that is basically it provides a summary of how energy efficient a building is and what fixes or upgrades are needed for that building to be more energy efficient. So what is typically looked at in an energy audit? First item is building envelope. This could be exterior walls, the roof, windows, doors. Typically look for air leakage, moisture penetration. The envelope is typically considered a low-hanging fruit for new construction, as it does have the biggest impact on energy conservation. Next item would be HVAC systems, where we may look at ventilation equipment, domestic hot water, heating system, boilers, etc. Then we get to control systems. Could look at lighting controls, dimmers, occupancy sensors, motion sensors, if the building has photocells for exterior lights. Also may look at the BMS system, what it has in place, control valves, automatic dampers. We'll also look at manual systems, which could be as simple as on-off switches into some standard valves. The next item would be electrical systems. This would usually be lighting fixture types. Are they fluorescent, LEDs? May look at the building power factor if it is needed. Look at harmonic distortion. This would require a power quality meter. May also look at power consumption. And that's where you would use utility bills to really evaluate the power consumption, or even use a power meter. And then the last thing would be utility bills such as gas, electric, and water. So when it comes to energy audits, you may wonder, well, what is the industry standard? Who provides direction regarding this? And this is where ASHRAE comes in. ASHRAE stands for American Society of Heating, Refrigeration, and Air Conditioning Engineers. The code used for energy audits is ASHRAE 211, with the latest being 2018 version. It's called the Standard for Commercial Building Energy Audits. And this provides direction for the various levels of an energy audit. And right now, there are 3 levels of an energy audit. And I will be getting into that on the next slide. So, first audit level is a level 1 audit. It's just essentially a walkthrough audit, a preliminary analysis. It's a very simple audit. It's a screening audit or a walkthrough audit, and it's the most basic. It involves basically minimal interviews with site operating personnel, a brief review of facility utility bills, and other operating data. And as I said, it is just a walkthrough of the facility, and it's all geared towards the identification of glaring areas of energy waste or inefficiency. So the data is then compiled and used for a preliminary energy use analysis, and a report will detail low cost or no cost measures and potential energy efficiency measures, which is acronym of EEM. They'll be for further study. So these corrective measures are briefly described. The report will kind of give you a quick estimate of implementation costs, potential operating cost savings, simple payback periods for those EEMs. They'll all be provided in that report. So for this level of audit, as I said, it's a very simple audit. So it's not sufficient for reaching a final decision on implementing proposed measures or EEMs, but it's adequate enough to prioritize energy efficiency projects and to assess the need for a more detailed audit. So, as I said, as nice as this sounds, what I just said, it's a very basic audit. So the next level of audit is a level 2 audit. This audit is it's detailed general audit of energy survey and analysis. So this, of course, it does include the preliminary ASHRAE level 1 analysis, but it also now includes a more detailed energy calculations and financial analysis. We typically will aim for about 2 to 3 years of data, of the gas, the electric, and the water bill. So then the financial analysis provides the facility owner with a comprehensive understanding of the financial benefits of implementing specific EEMs. So the detailed financial analysis is performed for each EEM based on implementation cost estimates, site-specific operating cost savings, and the customer's investment criteria. So not only are we just looking at the building itself, we will also talk with site personnel, maintenance staff to really see what's going on in the building. So sufficient detail in this type of an audit is provided to justify project implementation. So this audit can be used as a starting point for future building design projects. Typically in this level of audit, you will have a type of like an energy model that you will create. I'm not going to go into too much detail on that because Neil, in the presentation after this, will be going into further detail about energy modeling for a brand new building. However, it's very similar for an existing building. The same software is essentially used. So for this audit, this is the standard level of audit that is typically used for most facilities. Level 3 audit. This one is more intense. It takes more time. You really dig into the details of the building. So it's alternatively, it may be called a comprehensive audit, a detailed audit, or technical analysis audit. So it also expands in the level 2 audit. It includes everything from a level 1 and 2 audit, and it does provide a dynamic model of energy use characteristics of both the existing facility and all the EEMs that were identified. The building model is calibrated using actual utility data to provide realistic baseline for operating savings for proposed EEMs. So in this level of audit, as I said, you do look at the utility information, but there also typically will be some temporary meters that may be installed in strategic locations for a set amount of time to give you more data in addition to the utility data. And the last item I said on this slide, it says detailed financial and risk analysis with a high level of confidence. So because you're really digging into the building's nuts and bolts, you will have you'll have higher confidence in your EEMs. So you might wonder, okay, well, what type of equipment might be used? So it does depend on the ASHRAE audit level, but there's a lot of equipment that can be used, a lot of equipment that's available. So for spot measurements, some typical things might be a multimeter for power or a lux meter for lighting, temperature gun, thermometer, an anemometer for air velocity, a smoke pencil to see where the air is going, a manometer for duct pressure and velocity measurement, handheld hygrometer for humidity measurement, dB meter for HVAC noise, CO2 meter, basically confirm demand-based ventilation is working. And as I said, there's plenty more spot type measurements. For temporary metering, we may look at using data loggers, split core CTs, looking at trying to find motor run time. Essentially, it's measuring conditions over a short amount of time. Might only be a week, maybe 2 weeks. It depends on, I guess it depends on the level of detail desired. Permanent metering, this is where you'll have solid core CTs. You'll look at utility bill verification using their meters for the gas and electric. You could look at the review of the building automation system if there is one, or a SCADA type system if they do have one. And then last is infrared cameras. So these would be used to see possible high heat loss areas, missing insulation, electrical heat spots, and those type of things. So the next section I want to talk about are the energy audit, the benefits and the uses of them. So obviously, first one is it can save money by reducing operating expenses. So how much can it save? I did a lot of research, or I tried to do a lot of Google research online to find this value. It typically ranges from 5 to about 30% for what you could potentially save for a building. Older buildings will typically have higher potential savings opposed to a newer building, just based on the codes that were used at that time. It can increase comfort levels. So, there could be recommendations for improvements in insulation. Air sealing can reduce heat transfer, which leads to a more stable and efficiently heated and cooled space throughout your building. Or if, let's say, control systems or equipment aren't functioning correctly, this can result in a building with multiple areas of discomfort. Same thing as before, cold or overheated areas, possibly even lighting levels not adequate. And then the next one is reducing carbon footprint. So you can reduce the total greenhouse gases emissions, or GHGs, for your building. And then the last one is lowers exposure to energy price hikes. So it does vary in what province you're in, but currently right now, Alberta and BC do not have a time of use cost for electricity. Ontario does, but in my experience, a utility typically they'll place a building on a minimum consumption rate based on historical usage. So if you were to use that amount that your minimum is, you pay that bill. If you use less than it, you still have to pay that minimum amount. If you use more than that, you pay the minimum plus the difference of what you used additionally. So by making your building more energy efficient, you can reduce your the cost of electricity and on your building. Of course, another nice benefit in use is grants and rebates. So there's a long link I posted there, but basically it's the Government of Canada. They've created a website to find, which helps find financial incentives or programs available per province. So as I said in that note, the NRCan link, there's an interactive map of Canada where you can click on a province to see the available grants and rebates. I do have a little bit of time, so I wanted to show it to you briefly. I'm just going to hit pause here and see if I can go to it. So this is the Alberta or the Government of Canada website, which is a nice little interactive map for Canada, and you can click on each province to see what available grants or rebates are available for that province. So if I clicked on BC, here's BC Hydro, lots of BC Hydro, mainly just BC Hydro, but as you can see, there's multiple different types of grants for different type of buildings. Same thing for Alberta, multiple different type, lots of grants, different companies that are providing them. Also, some of them are from specific municipalities. So I'm just going to jump back to my presentation. One thing to note, though, is that some of these grants and rebates do require some type of an energy audit to be performed first before you can actually apply for it. And the other benefit of use of having an energy audit done is it can be used for forecasting and budgeting of future work for that building. Some disadvantages: the audit may have a use by date or limited useful life. This is basically as prices, as energy costs change over time. It could be based on grants that were available, so the price might not be the same as what it is in the audit. And for this reason, I'll go to the next one. So an energy audit isn't a design or work specification, so you can't take this energy audit and instantly just use it as a design for a new project. It's more of a stepping stone. So you still need to invest in design and specifications to get a project shovel ready. And doing an energy audit doesn't guarantee instant savings. You may end up learning your building is actually generally efficient and in good working order, but in our experience, it's rare to not have some EEMs that are recommended. And a disadvantage, it's kind of a thing that I think stands out just makes sense. It's a newer building. Sometimes a newer building, typically they may not see high energy savings, and this is because it's already energy efficient. So some challenges of unforeseen items. It can result in more energy being used. We had a situation where it was determined during the audit that multiple HVAC units were not functioning correctly or were not even running at all for a long time. So the building appeared to be using less energy than it should have normally been using, but the recommendations to get them back up and running resulted in more energy being used. Another one could be minimal existing information available. This could be drawings are non-existent, difficult to find, O&Ms stored in a box, hidden in someone's attic, or old equipment with an unreadable label. Getting utility metering data or getting utility metering details. This it depends on the type of meter that's already on site and if it's labeled properly. We had one project where there was hundreds of meters allocated for a small town, but they didn't have a clear description with the utility provider for what utility meter was for what building. And this was very difficult to confirm when we were doing an energy audit only on a small amount of these buildings, which meter was for which building. And then, of course, there could be some unique systems, such as an ice plant or a water treatment plant. Assumptions have to be made for how it's operated. This is nearing the end, the energy audit example. Example project was Frog Lake First Nations. Did an energy audit for multiple buildings. It was an admin building, rec center, career school, community hall, public works facility, social services daycare facility, and a water treatment plant. It was an ASHRAE level 2 audit. We went to site, observed items on site. There was financial analysis completed. RET Screen, that's the energy modeling software that was used on this project. But as I said, there's other energy modeling software we have used. And we provided an individual report for each building. The report compiled the EEMs, emissions, energy consumption, used simple payback method. It gave a nice summary of all that. This next slide has a lot of information. I'm going to try and simplify it, but this was at the beginning of our report. This is an example of done for the career school in Frog Lake. Just talked about the energy use, energy costs, equivalent CO2s, but basically the first three pie charts, electricity was only about 23% of the use, but the cost was 75%, and equivalent CO2 emissions was 75%. And this is because in Alberta, a significant portion of electricity generation comes from coal power plants or other fossil fuel sources. So electrical production results in more emissions than natural gas per unit of energy. That's specific to Alberta. It's different in other provinces where they might have hydropower. And then, of course, energy by use energy by end use, where it was specific to different items throughout the building, where we showed what was using the most energy. The largest three energy uses were heating of outdoor air for ventilation, heat loss through the envelope, and then lighting within the building. And of course, we did also show an emissions, equivalent CO2 emissions by end use, using those same things in the energy by end use, where with this in mind, basically selecting EEMs, which target these end uses, should have a strong impact on reducing the building's CO2 emissions. I can see we're getting near the end here, so we're running out of time almost. So this is one of my last, near the end of my slides here. This is a lot of information. Again, this was provided in the report, and this is a summary of all the EEMs that were investigated for that building. On the far right, I don't know if you probably can't see my mouse. On the far right is where it says EEM is recommended, and we would say yes or no. Not all of them are recommended, and this is typically based on the simple payback method. So the simple payback method is essentially the length of time it takes for the money saved to equal the money spent. If the simple payback value is less than or close to the expected system life, it is recommended. Depending on available grants and rebates at the time, an energy audit, or like when an energy audit is completed, some of these EEMs which are not recommended may result in actually being recommended with that added kind of boost in funding. At the very bottom of this, where it shows whole building performance EEMs, it was a summary of all the things we said yes to, and it also showed the overall estimated cost. And overall, as I'm trying to summarize there's a lot of data that was reviewed and calculations were completed to come up with these final values. Depending on the size of the building, our reports range from, for this specific project, they range from about 30 to 70 pages in length, with a nice summary of findings and recommendations at the very beginning. So in summary, what is an energy audit? It provides a summary of how energy efficient a building is, and what fixes or upgrades are needed to create that building more energy efficient. The various components of the building were looked at. I talked about the envelope, mechanical, electrical. Talked about the levels of an ASHRAE energy audit, and that there's three, two being the most common of energy audit completed. There's various types of equipment which may be used. Some of these items I don't want to repeat because I don't even know if I can say them properly. And then, of course, talked about the benefits, uses, disadvantages, and the challenges. That was money-saving opportunities, possible grants and rebates. And that's my presentation. Any questions?
Thank you, James, for that presentation. So we do have just one question here from Ruben. He says, it seems like sometimes level 2 audits are a blend with level 3 in that they both look at utility data, modeling, financial analysis, etc. So how do we firmly define this in the scope of work when we're discussing it with our client?
Well, in my mind, I think that would mainly come down to what the RFP says. If the client, this is where you'd have to ask the right questions when you're first bidding on that project. What is the client expecting, and kind of putting it out in clear terms, because the ASHRAE documentation does clearly kind of lay out what is required for level 2 and what is for level 3 and what is for level 1. When I was preparing this presentation, I did notice that ASHRAE has come to notice that there are a lot of audits that are being completed that say they might be a level 2 audit, but it doesn't provide all the information that is required to be considered level 2 audit. So when you say, how do we firmly define that it's in our scope? In my mind, I think you really need to define it first when you're bidding on the project and lay out what you're bidding on. That's what I'm thinking. Is there anything you think, Carl, that might be added to that?
I think it's important to note that the level 1, level 2, level 3 are in themselves pretty firmly defined. Those levels are from ASHRAE, and there is a nice description of exactly what is typically included and what is typically excluded from each level. So I think that would be a good starting point to start with that discussion, and then depending on what the client hopes to achieve through the audit process, we can help to guide that discussion. So James, we have a couple more questions that came in here. We've got one from Mark Ingalls, and he wants to know what is the training or certification that's required to do energy audits?
This is where this is kind of a gray area in my mind. What I've seen is that if you are an engineer, you can perform an energy audit. An energy audit seems to be more focused towards mechanical and architectural items, with electrical being kind of the low, maybe 10-20% of the audit. Training is helpful. So as I said, as Carl said, I took a course to become a certified energy manager, and essentially it was a very high-level look at what is required for an energy audit. However, I feel that being an engineer, you have added value with your construction experience and design experience to add to doing an energy audit. So do you need training or certification? To be honest, that's a hard one to answer. I don't know the exact answer to that one at this time, because I couldn't find a governing body. There is sort of a governing body in Canada. It's called CIET, which is trying to oversee the energy audit type of area. But as I said, if you're an engineer, you don't require to have that certification, because you already have the engineering certification to do it. So that's something that I think I'd have to look more into to really get a clear answer on.
Okay, and our final question is from Ali, and he wants to know how the end-of-life equipment replacement plays into an energy audit.
Well, I guess I'll have to ask you this, Carl, because you were involved with the Frog Lake energy audit for all those buildings, and I believe that was taken into account for the replacement of equipment. Is that correct? Did you guys take that into consideration?
Yeah, so for that particular project, that was to some extent why the energy audit was conducted in the first place. Quite often, you have that question as to whether we just replace equipment in kind with exactly what was there before, or do we make upgrades, understanding that the equipment is being completed anyway. So this is the cheapest point in the building's life to consider making those upgrades. So I think it's important to note that the two are fundamentally related, but they are different in that an energy audit is not necessarily done in conjunction with an upgrade project, but I would say that they're not necessarily, not specifically necessary when you're doing an equipment upgrade project, but I think that there are synergies between the two, and in my mind, it is pretty much the perfect time to do the energy audit because you're in a position to actually take advantage of those equipment upgrades. So I think we are out of time now for James's presentation.
I like Paul Jackman's question, but we don't have any time to answer right now.
Sorry about that, Paul. James will be available, I guess, after the presentations if you want to send him a message on Teams or get into contact with him by email. His email is there on his screen. You are welcome to do that. So now we are going to move to Neil. So our next presenter, Neil Markham, is from our Saskatoon office in AE, and he's going to be teaching us a little bit about energy modeling. Neil is a design technology from our water group, but despite being officially in the water group, he does have a strong passion for energy and is currently amassing a fairly intimidating profile of energy modeling experience. Neil has over 15 years of experience in design and manufacturing in general, and such he has worked with a bunch of really interesting technologies such as 3D scanning. So please welcome Neil and his presentation on energy modeling.
Hello, everyone. James is still showing his presentation, so I can't show mine yet. Excellent. So I'm Neil Markham, and this is my presentation on high-performance buildings when to energy model. I'd just like to start out by saying, as a person of Métis ancestry, I appreciate the acknowledgement of the First Nations land. I'm in Saskatoon, and we're in Treaty 6 territory. So we'll get started here. We'll just start out with the agenda. So what we're going to cover here, we'll just do a bit of an introduction. When do we use an energy model? What is an energy model? The code compliance and the compliance path. What can an energy model do for you? Summary, and then at the end we'll have the questions. And shortly, Carl should be posting a poll, and I'd appreciate it if we could all answer, just so I get an understanding of who's in the room and what kind of experience you have with energy modeling. I believe it's up right now. So, introduction. So the purpose of this presentation is a high-level introduction to energy modeling as it applies to AE. So the tool that I use is IES, but I believe the presentation, or at least the concepts, can apply to any software. And there's also a bit of a focus on the NECB, but again, any energy code, they're all kind of similar. So we're going to outline when and why we're going to use energy modeling as well. So why do we use energy models? So I think the number one reason is that it's kind of code driven. So it's to demonstrate compliance to code, to demonstrate long-term savings for the client or end user. So in your design, you might want to use an energy model just to get yourself some ROIs and things like that. A deep understanding of how the building is expected to perform. So you could use it as a design tool. Troubleshoot existing buildings, which is kind of goes hand in hand with James' presentation. So you could model a building that's existing and then tweak it to see how it will perform if you made some changes to the building. Optimizing the design would be just to make sure that you're sizing everything properly and you're not oversizing things. And then to validate your design as well. And that would be on the opposite end, make sure you're not undersizing something, just to make sure that the equipment that you choose is appropriate. So here we've just got a chart. This is from the NRCan website, and it's just showing the different provinces and kind of the codes that they're implementing currently. And we don't need to go through all of them. The last two kind of columns here are the NECB. So it's not implemented Canada-wide yet, but most provinces are implementing it. One thing that stuck out to me was Ontario doesn't have anything here, but I did look into it, and they have a supplementary standard, SB10, which includes ASHRAE 90.1, NECB 2015, and ASHRAE 189.1, which are all energy standards that you can use. So you can choose from any one of those three, and you'll be in compliance in Ontario. What is an energy model? So an energy model is a simulation of a proposed building's energy usage throughout a typical year. So there is a lot of data that is generated as a result of this simulation, and we can leverage this as designers. To list a few, you can get heating and cooling loads, you can get your annual energy cost and your return on investment, and you can use the software to quickly compare design options to see how it affects energy use. So it's quite easy to, for example, change the R value in your wall or roof and see how that's going to affect your yearly energy use and ultimately your yearly energy costs. So what information do we need for the energy model? So this is just kind of a quick pictorial, but basically it's kind of everything that goes into energy use. So, you know, your lighting, your R values on your walls, where your building is situated has a great effect. So for example, if you're in Vancouver or you're in Saskatoon, you're going to have, you know, your building's going to see different temperatures, and all that stuff is input into the model, and using that information you get a energy use for the year. So this is just a snapshot of the software. This is IES. IES is kind of an amalgamation of different modules. So I've got kind of three that we use the most. So this is the modeling portion. This is where you put in all your different spaces, and then you define each space as far as the materials that go into your walls and your roofs. You put your windows and doors and the R values for all of that stuff in there as well. The next shot is a 3D view of the building that you've modeled. So it's very useful. This one is kind of hard to see what you're doing, especially when you've got multiple levels. So a 3D view is very helpful to kind of see what you're doing and making sure you have a complete model. And then the third one is a module of the program that kind of lets you visualize the data. So once you run a simulation, you'll have, you know, all kinds of data that you can look at, and you can create these charts which will show you, for example, you can chart your internal air temperature over time. You can chart your energy usage in each room or for the whole building over a day, over a year. Really, it's just whatever you want to see, and you just kind of select what you want to see, and a chart will pop up for that. So it's very, very powerful as a design tool, and you can use this also to interrogate your model to make sure that you've modeled everything properly as well. So when do we use an energy model? So chronologically speaking, I would say you want to get the energy consultant in on the project as early as you can. Proposal stage is perfect. We can give advice on certain things at the outset, which might help you down the line. In practice, when we can't follow the prescriptive or trade-off approach to the applicable code, and I'll get into that right away. So what does this mean? We'll find out in the next couple slides. So code compliance, and I'm going to use NECB because that's kind of the code for Canada. In general, any building over 300 meters needs to conform to the NECB. So for people that are a little more imperial units friendly, that's about 3230 square feet. Buildings under 300 meters will need further evaluation, and they may be covered under the building code, but there are some certain situations where they still do need to be covered under NECB, so you just need to get some consultation on that. Additions over 10 meters squared need to conform to NECB. So 10 meters squared is about 100 feet squared, which is a 10 by 10 room, which is really small. So in essence, virtually all additions need to conform to NECB unless you're building a small lean-to or something like that. Renovations to existing structures fall under the building code. So if you're doing renovations to a building or you're retrofitting a building, that would fall under the building code. You don't have to necessarily follow NECB. Energy code compliance needs to be considered on every building project, and the earlier the better. So the compliance path. So we've got a prescriptive path, a trade-off path, and a compliance path. And the compliance path is basically an energy model. And I'll go into each of these right now. So the prescriptive approach is a method that involves conforming to the NECB requirements for envelope, performance, lighting, HVAC, service water, electrical system, and motors. And basically the way the prescriptive approach works is you just follow along line by line. Your roof has to be R this, your wall has to have this R value, your lighting, kind of wattage density value has to follow a certain a number. Your HVAC systems have to conform. So you're basically, if you're using the prescriptive approach when it comes to getting your building permit, you're basically just filling out a form line by line and ensuring that your building is meeting each line. In cold climates, the envelope is usually where we're going to fall short, and often it can be cost prohibitive to conform to the R values required. So, you might have a wall that you need 10 inches of insulation, and that's kind of where you might want to go to another approach so that you don't have to do that. In most cases, the other parts are easy to achieve under the prescriptive approach, especially right now. They kind of base their standards on current practice to start with, so it's pretty easy to meet in the other areas, not building envelope. And like I said, so the trade-off approach may be an option. Buildings with excessive glazing will likely need an energy model. So the NECB provides for a certain amount of windows depending on your degree design days. And so degree design days are basically how many hours your building is below a certain temperature. Basically what that is saying is this many hours your building is going to be in a heating mode. And depending on that number, that will dictate how many windows you can have. So for Saskatchewan, for example, it's usually about 30%. So if you go above that, you're pretty much going to be stuck. You're going to have to do an energy model, especially if you're doing like an office building that's mostly windows. So the trade-off approach, you can use it in each area, but it's really only practical to use on the envelope. So what the trade-off approach does is you're trading performance in one area for performance in another area. So for example, if you increase your window R value by going to like a triple glazed argon filled window, maybe you can reduce your R value in your walls, or you can increase your R value in your roof and reduce your R values somewhere else. You can use the trade-off approach in other areas, but it's a bit cumbersome to do and not really recommended. So if the trade-off approach isn't going to work for you, that's going to kind of lead you towards an energy model. This is just a chart. This is actually right out of the NECB, and it kind of just shows you the decision-making process of how you're going to comply to the code. So it's kind of pictorially showing you what we just went through. Mostly so you don't think I just made it up. This is right out of the code, and this is the way we have to do it. So in summary, energy models can help with code compliance, help understand building performance, compare design options, provide heat gain and loss calcs and QA verification, maximize overall building efficiency, inform construction methods when prescriptive methods become cumbersome and expensive, and troubleshoot existing buildings. If you only take away one thing from this presentation, it is this: involve the energy modeling team as early as possible. This will save you money in the long term. And just to expand on that, if you come to us at 90% and ask us to do an energy model, we can do that. But if we come back to you and say you need to increase the R value in your walls, you're going to have big time rework, and I don't think you're going to be very happy as a project manager. So yeah, that's my big message. Get us involved early and you shall have success. Any questions?
So I don't see any questions for you yet, Neil. There might be a few coming, but I've got a quick question for you that
sure
you might mind answering. So as a mechanical person, people often come to me, and the most typical question that I hear is, how long does an energy model take? How many hours should we be budgeting for? I think there is some surprise when I give them my opinion on that, but maybe you can speak to it.
I'd be curious to hear what your opinion is.
I haven't done very many models myself, but typically for something in eQuest, if it's let's say a 1 to 2 story building with 3 or 4 different air systems, it does take a week and a half to 2 weeks to complete.
Yeah, that's about in line with us with IES. I would say for a simple building, we're looking at 40 hours of modeling time and then 40 hours of time to build up the HVAC systems and then prepare a report. So a minimum of 80 hours, and then depending on building complexity, it can go up from there.
We did receive a question in from Job Chua. Wants to know how much better are energy modeled buildings versus prescripted ones?
Well, I guess that depends on what you mean by better. I'm assuming you mean energy usage wise. So really that's up to the designer as to how much better you want to be. So you can use an energy model, and you can, so basically the what your report is going to tell you at the end is how much better your design building is than a base model. And the base model is basically a prescriptive building. So depending on how you design it, you might have a building that's 10% better than a prescriptive building. But if you want to, you can be right on the money, and it'll be exactly the same. It really just depends on what your goals are. And sometimes the goals are stated by the client. They may be. So they might say, well, we want to be 20% better than the prescriptive approach. So it's really up to the designer, and I guess ultimately up to the client where they want to go with that.
Excellent. Another question in from Paul. Wants to know, when you're involved early in an energy modeling process on a new building, how would you model something that is very subject to change?
Yeah, that's always the challenge, isn't it? I would say that the way, at least in the models that I've been involved in, the architects kind of define what their targets are as far as R values on the envelope, because you want to get that envelope designed and kind of set, not in stone, but we'll say very hard plasticine early, so that you don't have those changes happening. The HVAC side is a little easier to change later on, but that's kind of why you want to get the energy model kind of done early. The other thing I can say is we can model a whole building as one space. Basically everything is spaces, so you would have office as a space, a washroom as a space. We can define the whole building as a space and kind of put a universal wall R value and a roof value, and that kind of gives us an idea of what we're going to expect in terms of the overall building performance, and it can somewhat inform what we need to do with R values, especially if we know a percentage of windows and stuff like that. So the earlier the better is always the case, and we can tweak the model as we go. Of course, the more times you make changes to the design, and we have to go back and change the model, that's going to increase the cost of the project.
Okay. Question from Ali. So if you do an energy model during the design phase, do you then have to go back in construction and audit what was built? And then in addition to that, what happens if the readings or the energy consumption after it's constructed is very different than what you expected?
Right. So there is no provisions for that right now. The only kind of auditing there is you have to have your model audited by a second party, and that can be internal, it can be external. But as far as after construction, right now there's no provision for that. I would expect maybe in the future you might see something like that, but as it stands right now, there's no real verification process as far as does the building actually perform the way that it was modeled.
Next question is from James. Wants to know, which is the most common compliance path when you're looking at NECB?
Yeah, that That's a tough one to answer right now, especially in Saskatchewan. We've had the code for about, what is it, a year or 2 years. I don't know that I can say one's more common than the other. I can say that prescriptive is the easiest, but using the prescriptive method will probably or possibly drive up costs, construction costs, just based on the R values required, at least in colder climates. But if you use a prescriptive path, you don't have to use the energy model. But just going ballpark, if an energy model is costing you $15,000 and it's saving you $50,000 in construction costs, it probably makes sense to go that way. So really, another reason to get, by consulting an energy consultant, you're not locking us in for a model. You're just getting our advice on what path to take. We might tell you that, well, you know what, prescription model actually makes sense here, and go that way.
Great. Question from Shaney. Wants to know, have you used the energy models to generate building heating and cooling load data? Often there's two sets of calculations completed side by side between the mechanical team, who's using probably HAPS or TRACE, and the energy modeling team.
Yeah. So that's kind of a side benefit or gravy of using the model, is these heat load calcs are kind of built into the software. So I'm on a project right now where we are actually using IES to generate these calculations. You can use them as a QA tool if you want. So in the project that I'm working on, we're subbing for another firm, and they are using IES, and they've done their own energy model. So we can compare our numbers and see, kind of use that as a gut check, a QA. But yes, very often we'll use IES outputs to compare against something like HAP or block load, and kind of see where the numbers are. So the one that I am thinking of in specific, we were like within 10% of the load. So.
Okay. Thank you very much, Neil. I think that's all the time that we have for questions. I think we actually answered all the questions on this presentation, so that's great
Good.
to see. So I believe there's a 30-minute break now before session 4 starts, so everybody can return to the lobby and make use of those networking sessions. Thank you very much, everyone, for attending.